simplifying algebraic fractions is conceptually very similar to simplifying non-algebraic fractions. So firstly, let's pin down, what do we mean by simplify? Simplifying is when we cancel factors that are top and bottom. So the way I would normally just do this is I would do 18 over 27. I'd see that you can divide top and bottom by 3, and that would give me 6 over 9. I can divide top and bottom by 3 again and get 2/3. That is, however, a bit of a haphazard approach. So let's break down what we're actually doing. Well, what we're actually doing is we are splitting 18 and 27 into their prime factors. So 18 is 2 times 3 squared, and 27 is 3 cubed. Okay? And so what we're doing here is we're going, well, how many 2's do I have top? I got 1, 2 top, 2's bottom? None. So I've definitely got a 2 left over. Then I'm going, well, how about 3's? Well, I've got 3 squared on top and 3 cubed on bottom. 3 squared means 3 times 3. 3 cubed means 3 times 3 times 3. So I can cancel these two, right, 2 of the 3's, to get rid of 2 of the 3's there. I'm left with just 3 on the bottom. Comes out with the same answer, unsurprisingly, but this method is conceptually almost identical to what we're going to do with algebra. So let's move on to that. When we have something here, like 9y over 3y, I'm going to break it down, and we get 3 squared y over 3y. Right, you can see each of the individual terms. You've got number of 3's, number of y's, and this is just like what we did up here. When we broke it down, we had numbers of 2's and numbers of 3's. So, doing that, we go, we've got 3 squared on top, that means 3 times 3. Got 3 on the bottom, I can cancel the 3 with one of those 3's. I've got a y on the top, a y on the bottom, so, and anything divided by itself is 1, so they cancel. So that comes out as 3. Not too bad. Next one, 4x squared. Okay, well 4 is 2 squared. And I should mention that doing this timesing out method that I'm doing here isn't necessary. If you can do it using this, that's absolutely fine. I'm just trying to make it absolutely clear what we're doing. So, here, broken up, 2 squared times x squared, 2 times 3 times x. Right, let's look at my 2's top and bottom. I have 2 2's on the top, 2 times 2, 2 squared, 1 2 on the bottom, so I can cancel that 2 with that 2. Okay, that 2 there being, because it's a squared, now I've crossed it out, it's now 2 to the 1 or just 2. There are no 3's on the top, so I leave the 3 alone. I've got an x squared on the top and x on the bottom, so I'm going to cancel my x and the squared. Right, so now what I'm left with is 2x on the top and 3 on the bottom. And it's always worth at this point just double checking, are there any factors top and bottom that cancel? Nope, 2's, 3's and x's, they do not go into each other. And this works no matter how hard the problem is. It's going to work on this too. So 12 is 2 squared times 3. And we've still got x squared, y times p cubed. And on the bottom, we have 2 times 3 squared times x times y times p cubed. And we're just going to do it for every single term. 2 squared, 2. Okay, so we're going to cancel 2 top and bottom. 3 squared. Okay, cool. We're going to cancel a 3 top and bottom. X squared and x. We cancel x top and bottom. And we've got a y squared on the bottom. Sorry, I missed the squared symbol out. And we've got a y on top. So that y cancels with the squared. P cubed over p cubed. Anything divided by itself is 1. Therefore, what we are left with is 2x over 3y. Nice and simple. Okay, I just want to mention one thing as I realise that all of my examples did something very similar. If I gave you x cubed divided by x, what you would do is you'd cancel the x, you cancel the 3, but it wouldn't just go away, become a 2. We're reducing it by 1, because when you divide x cubed by x, you have x times x times x, that's x cubed, x times x is x squared. Okay, that's just a little aside to make sure I didn't throw you with that. That's it though. That is how we deal with simplifying algebraic fractions. I hope that's all made sense to you.